Calorie.
The name calorie is used for two units of energy. The small calorie or gram calorie, symbol, cal, is the approximate amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. The large calorie, kilogram calorie, kilocalorie, dietary calorie, nutritionists calorie, nutritional calorie, calorie, capital C, or food calorie, symbol, cal, equiv, kilocalorie, is approximately the amount of energy needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. The large calorie is thus equal to 1,000 small calories or 1 kilocalorie, symbol, kilocalorie. Although these units are part of the metric system, they have been superseded in the international system of units by the joule. 1 small calorie is approximately 4.2 joules, so 1 large calorie is about 4.2 kilojoules. The factor used to convert calories to joules at a given temperature is numerically equivalent to the specific heat capacity of water expressed in joules per Kelvin per gram or per kilogram. The precise conversion factor depends on the definition adopted. In spite of its non-official status, the large calorie is still widely used as a unit of food energy in the US, UK and some other Western countries. The small calorie is also often used for measurements in chemistry, although the amounts involved are typically recorded in kilocalories. The calorie was first defined by Nicolas Clement in 1824 as a unit of heat, and entered French and English dictionaries between 1841 and 1867. The word comes from Latin cala meaning heat.
Definitions.
The energy needed to increase the temperature of a given mass of water by 1 degc depends on the atmospheric pressure and the starting temperature. Accordingly, several different precise definitions of the calorie have been used. The pressure is usually taken to be the standard atmospheric pressure, 101.325 kilopascals. The temperature increase can be expressed as 1 Kelvin, which means the same as an increment of 1 degree Celsius. A figure depends on the conversion factor between international joules and absolute, modern, joules. Using the mean international ohm and volt, 1.000490, 1.00034 V, the international joule is about 1.00019 J, using the US international ohm and volt, 1.0004950, 1.0003330 V. It is about 1.000165 J, giving 4.18684 J and 4.18674 J, respectively.
Usage.
The calorie was first defined specifically to measure energy in the form of heat, especially in experimental calorimetry.
Nutrition.
In nutritional contexts, the kilojoule, kJ, is the SI unit of food energy. However, the calorie and kilocalorie are still in common use. In these contexts, confusingly, the word calorie and kilocalorie refer to equivalent units, the former to the large calorie and the latter to 1,000 small calories. Sometimes, in an attempt to avoid confusion, the large calorie is written as calorie, with a capital C. This convention is not always followed, and not explained to the average person clearly. These quantities are often used for the total amount of food energy, for example, in a meal, and for the specific energy, namely amount of energy per unit of mass, for example calories per gram, calories per serving. Nutritional requirements or intakes are often expressed in calories per day.
Chemistry.
In scientific contexts, the term calorie almost always refers to the small calorie. Even though it is not an SI unit, it is still used in chemistry. For example, the energy released in a chemical reaction per mole of reagent is occasionally expressed in kilocalories per mole. Traditionally, this use was largely due to the ease with which it could be calculated in laboratory reactions, especially in aqueous solution, a volume of reagent dissolved in water forming a solution, with concentration expressed in moles per liter. 1 liter weighing 1 kilogram, will induce a temperature change in degrees Celsius in the total volume of water solvent, and these quantities, volume, molar concentration and temperature change, can then be used to calculate energy per mole. It is also occasionally used to specify energy quantities that relate to reaction energy, such as enthalpy of formation and the size of activation barriers. However, its use is being superseded by the SI unit, the joule, and multiples thereof such as the kilojoule.